Good evening, everyone. So before I start module 3, regression analysis, let me give you the answers of or solution of week 2 related the four problems of hypothesis testing. So because I received a couple of emails that the data is not equal, there are 10 bags data on international and 15 bags on domestic, how we can do it's not equal. So I'm just going to explain one by one. I mean, briefly all the four problems, and then we will go on week 3. So as you can see, this is my mini tab. And here I have the data of international and domestic. So first thing first. Hello, little one. Who is there? So as you know, since we have two data set, we are using two sample t-test. And here, for example, we have the data in each column. The first column is international, the second is domestic. Now we go on options. Here it is clearly given in the question 95%, 5% alpha value, which is like 95% confidence level. So I'm just putting exactly the same thing. So which is here. And now hypothesized difference is 0. 0 means here we have the H0 null hypothesis is mu international minus mu domestic equal to 0. And what is the alternate? Alternate here, it is asking in the question to check international, just a minute. It is asking mean weight of international bag is greater. So we are just going to check whether it is greater or not. Here we go. So what would be our, so this is the one thing, null hypothesis. Alternative hypothesis is mu international minus mu domestic is greater than 0. Why? Because it is asking mu international is, or international bags are higher. So this, if this is higher and this is lower, then it would be greater than. So we are just going to check the same concept here. Look into this. Difference is greater than. And now you just go here. Now look into this. There are 10, this is, all the things here. This is all. Now look into this. T value is 3.16. Degree of freedom is 10. What is the p value? P value
0.005,
which is less than 1%, or you can say 0.5%. And our alpha is 0.05, and this is
less than
1%. So I would say 0.005 or
Dr. Devletti, I've got a quick question for you. So when you're setting that up, one of the things that some of the students and I noticed is whether or not you have that assume equal variances checkbox checked. you seem to largely get the same values back, except for the degrees of freedom seems to go up significantly. And I know I had marked that on mine. So I noticed that was higher. Can you explain when you should use that option and when you shouldn't, and any other impacts that it might have?
Yeah, I already I gave this hint. Now I'm going to give you when do we use the equal or unequal variance. For example, since this is international, this is here we can't say this is equal. Whenever you have any feeling that these variants are equal, and then the calculation becomes little complicated, whenever you think these variations could be equal, and then for checking that we need to go into that we skip that chapter, and that is called ANOVA, analysis of variance. So let me show you here.
It'd be like problem 3, which uses equal variance.
Yeah, so for example, here, one-way ANOVA, analysis of means. Here we can go, this is the chapter, I think in book, this is the chapter number 12, or I forgot in the book. It says which one is varying, how they are varying, whether both are representing same population. So normally it is given in the question whether we need to assume equal or unequal. So in our questions, you get exactly the same feeling, same instructions. Do we need to assume equal variance, or do we need to assume unequal? For example, in our, here, let me show you, I think. Here we have, for example.
It's problem 3.
Yeah, for example, at level of significance, is there a difference between the average size of home of two neighbors? State your hypothesis. Just a minute. So let me go into the principle of the assuming equal or unequal variance. So before, how do we do? If you have sample, just go here. State, ANOVA, one way. Here you can, or analysis. Here you can, let me plot also. Just a minute. Let me clear this then only just. Here you can see analysis of variance. And it comes, when there are two things, two samples, and both samples have, if they have equal variance, then they will represent. So for example, this is a grouping, and I think I need to cover the entire chapter of ANOVA. So in nutshell, I can say, in our problem, it is clearly given. If not given, then you are not going to assume equal variance. The second thing is that equal variance, when you think, both the population are representing equal variance, or means, for example, if you look into the house prices in Spokane County and one more county, and if you feel, okay, the house pricing and the variance in the both region are approximately same, then you can assume equal variance. The calculation will differ marginally in decimal. However, only one point which is remains same, which is differ, is degree of freedom. So for example, in this, if suppose unequal variance has 20 degree, I mean there is 1 degree of freedom difference between equal or unequal. For example, if you take a simple or a small sample. So, and one more thing, I think I am going to draw here on whiteboard in order to explain. Here we go. One more thing. For example, this is the
Shauna, join the meeting.
This is sample 1. This is the entire population, for example. This is entire population, and try to understand this concept. This is the sample 1, and these are upper limit and lower limit, and this is the sample mean. That means this sample 1 is representing the true population mean. Okay. If you think the second situation, in second situation, this sample is here, and it is, what is this sample? This is sample mean, and this is, for example, population mean. This sample is not representing the true population. That means you can't assume the equal variance here. However, in this case, here you can say both samples are representing the true population mean. We can assume equal variance. I think I need to explain entire ANOVA chapter in order to explain this, equal and unequal variance.
Well, I don't think that's necessary. I just wanted to make sure that if we had used assume equal variances on that first problem, like I said, the data looked mostly the same. I think I only noticed the degrees of freedom had changed. I just wanted to make sure that wasn't like negatively impacting some other part of the problem.
That is
so
there,
I think we're good there.
I think it just changes degrees of freedom.
Yeah, that was the
one
problem.
Degree of freedom would be different. So, for example, here, if you see, just share my screen. Here, okay, here is the, for example, you can see. Just a minute. Yeah, this is the perfect exact explanation. Analysis of, what is the meaning of ANOVA? The full form of ANOVA is analysis of variance. Look into the international, look into the domestic. For example, we did this. So this is ending, this is ending here.
And people who are not talking go on mute.
And here you can see it is not overlapped. So we can't assume equal variance because they are different. Both the samples are different. Here you can see this is going lower limit. They are not overlapping. If suppose this value is like here, okay, you can say they are overlapping. They represent truly one, they have equal variance. So this is the one of the example which can be given. When do we assume equal variance? So always look into the, now third question, I just go here, clear all the drawing, and just a minute, I go again on stat, basic ANOVA, one way, and now I get this third. Okay, I think this is the one. Here you can see. Can you see this? This the green wood and this is a pine wood. If you look into this, they are fairly and closely representing the true population mean of one entire population. In this case, you can assume. So this is the theory behind equal and unequal. I don't want to make it complicated. Otherwise, it could be one more chapter. So here, this is the simple, and I represented in whiteboard, which is exactly the same meaning. In Minitab, we get this picture. If you see, this picture is very fairly close, they are overlapping properly, then we can assume equal variance. If they are together, let me do one more example. It's ANOVA one way, and look me, for example, team A and team B. This is a step, this is basically a, let me take a before or after. However, in pairwise comparison or a paired sample, let me go through this. Here they are also, you can say, because they are representing a same population. Look into the fourth, and now one more time, international or so before clicking this box, we need to check this one more thing. And here you can see they are mostly paired tests. So something after, before, or in same condition, team A or team B. So we don't use the ANOVA, but we don't use the equal or unequal because that is a separate case. However, this is the test to do before checking that box. I hope I am able to answer your question. Now let me go to.
Thank you.
You're welcome. What we were doing? Yeah, I was just solving the problems. Yeah, so the first question state two sample t-test, and this was the case, and difference was, so I am not assuming this, okay. And here, what we got? So the p-value is less than the significance level. That means we reject null hypothesis and we accept alternative hypothesis. That means, what is the alternative hypothesis? This minus this is greater than 0. That means mu1 is higher, which is international is higher, certainly. And this is the number one case. And rest of second question comes here related to where we are. Variance greater for bags, here we are checking the variance. And as I said in the last class that, you can do the hypothesis testing based on proportion, based on variance or standard deviation, or based on mean. So this is asking a variance is greater for bags for international flight. So we are going to check that. So I go here, stat, and here we are going to check two variance. Okay, and two variance, here we have options. We have, and okay, we have international. What is the situation in this case? null hypothesis, sigma 1 upon sigma 2 square, this is denoted as variance, equal to 1. So this is the null hypothesis. Alternative hypothesis is, it is saying again, international variance is high. Sigma 1 square divided by sigma 2 square is greater than 1. If greater than 1, that means this value, or the international flight baggage are higher, then only this factor becomes more than 1, is it? So I'm just going to, okay, I think I checked the, okay, ratio is greater than. Here we can, for example, this is F value and this is P value. Now you can conclude without my statement, the P value is less than the significance level. That means the null hypothesis is fair. Alternative hypothesis is accepted. That is the international flight variance is higher than domestic flights. Is it making sense?
So for this question, is it okay if we had the null hypothesis as less than or equal to 1? Since generally...
Yeah, that's fine. Yeah, technically that is fine. But
okay, because Minitab doesn't
I'm just
have those options.
Yeah, so I'm just going through the Minitab. It is, you can have, exactly, you can point this less than or equal to this much. Yeah, so that's fine. So this is the first question. Now the second question is about so this is basically, so basically in same community, you can understand the data. This is the same community. So this is after or before. Can you see after or before situation? So this is a paired sample t-test, paired sample test. In the same county, 2 observations are there, before or after. So what I'm going to do, I'm going to run stat basic, then we have paired test. For example, here I'm just going to, and question is before or after, which, so normally difference is measured on the basis of greater after value minus, so here after is first, before is later. Options, what is the significance level? Just a bit, 5% again. So here we go for 5%. Hypothesized difference is 0. What is the alternative hypothesis? Is less than. Here you can now conclude. Based on this, T calculated value is minus 1.98, and null and alternative hypothesis are, yeah, these are null and alternative hypothesis. P value is 0.41%, and what is the alternative significance level is 5%. This is less than that. Therefore, the difference is less than. So the statement says, state the hypothesis whether the number of incident declined certainly, because after minus previous is less than 0. That means declined, certainly. So we conclude that, yeah, because after and before is less than 0. Is it making sense? Now we go to the third problem. The third problem is 9 homes, and at 10% significant, is there a difference between average size of home in 2 neighborhood? And look into that. So and what test are we going to use?
Two-tailed.
Exactly. And this is greenwood. Sorry. This is greenwood. This is pinewood. Options. So we are just going to check a very simple. It's a 0 or difference is 0 or not 0. Okay. Can you see the value is, t value is, and the p value is greater than 5. I think what is the 5% we took? I don't know what value I used or I did not use. So basic statistics. Yeah, so it's a 95%, and the question also says, no, we have to check the 90%.
So it's 0.90.
Yeah, 0.90, yes. Yeah, because by default it takes 90. So the p-value is 20%, and the alpha is 10%. So the p-value is greater than, and we accept the null hypothesis. Null hypothesis says there's no difference, and we can conclude the same thing. And the technical statement, we fail to reject null hypothesis. That means there is no difference between these two, greenwood and pinewood. So, and the last question. The last question is again, so this is clearly this is paired sample t-test. So I go here because it is team A and B and the patient, the same patient. So pair T sample, and I go here. Now look into that. It is asking, it is 0 or no 0. So the first thing is team A and the second thing is TB. Options, what we are going to check, difference is 0 or not 0. At what level of significance? At 10%. So here again I put 9.
90.
And I go here. The t value is this, p value is this. So our p value, alpha is 10%, p value is 10.5%. So p value is greater than the alpha value, and we accept the null hypothesis. That means we fail to reject null hypothesis. That means there is no difference between team A and team B. So this was the homework that we had last week. I hope it was not very difficult. But certainly, this subject cannot be done without understanding the concept and without understanding. This is not like marketing or human resource subject. Now I'm going on the regression part, and that too multiple regression. Before going into that, I would like to explain a concept of regression, and then we can go on. So little bit, it will take 10-15 minutes. So for example, if I say I plot a graph between, let's say, experience and then salary. Let's say if someone has 0 experience and get first job, the salary is low. As experience go, the salary goes. So for example, this is x-axis, this is y-axis. So this is called intercept, or I would say this is called alpha. So this is intercept and it is called experience. And then we are going to check the gradient, which is called slope. For example, I take 2 points on this line. These are the 2 points. I draw the vertical and horizontal lines from those points. So for example, this difference is like del salary, or this is called del experience. So the gradient, or you can say slope, is equal to gradient of salary and gradient of experience. So this is called slope, or it is also known as gradient. And how if suppose I have this formula, salary equal to 50,000 plus 3, I would say 0.15 experience, or let me make it whole number here, 2 experience. So suppose if I know I have 5 years of experience, what would be my salary? If I have my 5 years of experience, 2 into 5, which is 10,
60,000.
6 plus 50, which would be, my salary would be 60K. So basically, this is 2-dimensional regression. It is simplest regression. One is dependent variable and one is independent variable. And we can clearly see in the picture of, in 2 dimension. If suppose this is multi-dimension, we can't see the picture. And how we can see, for example, here, this is alpha, this is experience, this is the second constant, this is third constant, n constant. And therefore multiple regression is used where you have multiple independent factors like experience, like education, like other factors also contribute in your salary. So this is what. So basically, these are the different factors. And what we check in, okay, if suppose this factor, or I would say this is beta, slope is beta. Now, if I say here, null hypothesis says alpha 1, alpha 2, alpha 3, or all the factors, different name, are all equal to 0. And null hypothesis say H1 says alpha 1, all are not equal to 0. That means if suppose this factor, this constant is 0, that means this factor will not have any impact in the equation. So how we can check? Again, very simple thing. So now I'm just going to show using one simple data set. Clear all drawing. So look into this. I have this data set here. I hope you can see. This is the data set. It's about Indian students data set. Here, this is the chance, in mostly around there are like, every year, like, if I remember, around 1.1 million international students are here in United States from other countries to pursue their masters and different education. Around 300,000 Indian students are also there. Out of there, every year 20,000 new Indian students come in United States for doing their masters and higher education. And this is the data. For international students, you need to have GRE score, you need to have English score, English language score, which is TOEFL. A statement of purpose is important. Letter of recommendations are important. CGPA or GPA that you call, which is how you performed in your previous education, that's GPA. In India, it's not 4-point. In India, it's a 10-point GPA scale. You are applying for research university or you are applying for non-research university. One is research, 0 is not. And what is the chance of admission? This is like out of 100%, 92%, 76%. So basically, this is multiple regression problem. If suppose I want to check my TOEFL score is this much, my GRE score is this much, my CGPA is this much, my letter of recommendation or statement of purpose is this much, and what are the chances of my admission? So based on this is a real data of 500 students. Let me show you. For example, state. Here we are just going to use one option here in this chapter. Regression, can you see? This is the regression. Under regression, we are going to use regression and fit regression model. So we are going to use fit regression model. Okay, what is the response? The chance of admission. What are the dependent variable? On what admission depends? GRE score, TOEFL score, statement of purpose, letter of recommendation, research, and what I miss, university rating. It also depends what kind of university you are in. 5-star university, 4-star university is also important. Categorical variables means you are applying for research university or non-research university. Categorical, where you have categories. So even I can put university rating in here because that is categorical. So university rating is here, and where is the research here? Now I'm not going to by default, I'm just going to check this. Okay, categorical is only where you have 2 options. So let me go again.
Yeah, I thought you couldn't use anything but 0 and 1 for categorical.
Yeah. So just, I think fit regression model. So I just use here. The rating will be here, and then only, categorical, which is here, research 1. Now I'm just going to. So here you can see this is my the equation. For 0 means non-research university, for 1 this is. So if I want to go for research university prediction, I can use the upper one, I can use the lower one. So this is the equation. If now so this is the equation, and based on that I'm going over there later on. First, now I would like to check, based on this equation, what are the chances if I have x, y, z, any values in this. So state, regression. Here we have predict option. Can you see this? Predict option. Under predict, here I want to predict for, I have GRE score like 328. TOEFL score out of 120, like I have 118. A statement of purpose is on 5 point, which I say 4.3. Letter of recommendation, I have 4.0. CGPA is my 9.0, and university rating is like I'm applying for 4-star, and research I'm applying for research university. So what are my, based on this equation, I'm just trying to see what are my chances of admission. Here you can see, based on these, score I have, so this is fit value with 95%, and this is 95% prediction interval. This is 95% confidence interval, standard error of fit, and this is my chances of admission is 84.9%, or I can say 85% when I have these scores. So here I can see this is my chance of, with still 5%, 5% chances that it can go, the confidence interval is between this, means 95% confidence is this, with prediction interval is still, I having this, I cannot get the admission. So yeah, now I come back on my regression analysis part, stat basic, regression fit model, and okay, look into this. So basically you can see this is very first constant, which is minus 1.26 here. For example, this is this is a first constant, and p-value is 0. That means what we can understand here, for example, p-value is 0. This we use ANOVA table. First thing, all null hypothesis is all 0. Means all coefficients are 0. Alternative is not 0. So if p-value is less than 5%, because by default it is coming 5%, that means it is not 0. That means this intercept has. Now look into the ZRE score, look into other TOEFL and other things, and you will see regression is this much, ZRE having this much, TOEFL has this much, and all other things are there. Here you can see TOEFL statement of purpose, all constant. This is all coefficient. GRE, this is less than 2%. So you can see all these coefficients are significant or are non-zero. Statement of purpose is 72%, which is higher than certainly in larger, statement purpose will not have that impact. Letter of recommendation is again 0. CGPA is again 0. University rating is higher. So, in this model, ASOP and university rating is not that important in admission. So now we come to this part, which is standard error of the entire, means if all predictors are perfect, then this standard error would be 0. R square is like this explains the relationship between dependent variable and independent variables. Means 82% changes in chance of admissions are due to GRE, TOEFL, university rating, SOP, CGPA, LOR, and research. Means this is called also, cause and effect relationship. Means there is 82% chances or 82% cause in the admission due to all these independent variables. Means changes in chance of admission can be explained by these variables, these independent variables, by 82.19%. That means 82% is the cause, and the value of R square can be vary between 0 to 1. Let me show you. R square can be between 0 to 1. That means 1 means 100%. 0 means no percent. So 82% is really good. So basically these things, there could be 12 or 18% different aspects of admission, but 82% admission, chance of admission can be explained by these 1, 2, 3, 4, 5, 6 independent variables. What it
quick question.
Yes, please.
With the R squared adjusted so close to the R squared, how is
Yes.
that the case when 2 of the 7 variables are not significant?
Yeah. So if if 2 of the 7 variables or 6 variables, I believe. So this is okay. 2 of the 7 variables are not adjusted, are little bit precise value. That is little bit always less than the R square. So always whenever you do any regression analysis, R square is little bit finer than or little bit lesser value of than R square. So for example here 82.19, so this is like 81 point. If you have like 88, it could be like 87 point something. So this is more precise value of R square. But in practical we just use this. Like your question is, out of these 7, two variables are not significant, means 2 variables are not playing significant role. And what is your question? Sorry, I just.
But shouldn't that have a bigger impact on the R squared adjusted than it does right now? Because it looks like R squared and R squared adjusted are really close. But if R squared adjusted basically says that you have variables that are redundant, are not helpful, we have 2 out of the 7. That seems like a bigger number than what R squared adjusted is showing.
Yes.
It's showing that there's not really that many variables that are not that significant in there.
Yeah. So I'm just going to do a quick practical here. So these are the 2 things which are not significant. One is research, where is research, and the second is SOP. I'm just going to run a simple regression where I'm not going to count 2 variables. University rating is not significant. Oh, sorry, SOP is also. SOP, this is CGPA is important, and research is, I think we are fine. 1. So here, what we got? Here you can see R square is still 82%. So means if 2 variables are not significant, if I'm just using 5 of them, they are still showing 82% in regression coefficient, and R square is earlier, I don't know, it was 81 point. So 81.94 means there's not much change in that. And you can see now all the coefficients are less than 5%. So
shouldn't that have improved the R squared adjusted though?
You can see it is not. I think you can see 81.88 and here 81.94. So R adjusted R square, the formula, when we look into that, I'm just going to show you here. Because here, if we go on the formula, then we can understand. To be
page 555 for anybody who's looking at the book.
Here you can see. So for example, you look on R square here, this is the formula. R square is equal to this minus this. and adjusted R square is, so this is little bit finer when you look into the, here the denominator n minus k minus 1. Here it is just SSE and SST, where it is, here you can see n minus k minus 1 and n minus 1. So basically, if you look into n minus 1, n minus, this k factor is little bit, extra, which results in a smaller adjusted R square than R square. If you look into the formula, always this would be less than the R square. Am I able to answer your question? Hello?
Sorry, I guess I see that the K factor is really the big difference, but I guess according to the book, it's telling you that they're used as predictions if you see a variant or at least a big variance between R squared and R squared adjusted. But we can see based on the regression analysis that two of them are kind of useless. So I guess I'm kind of confused if the book's telling me that R squared adjusted, the variance between R squared and R squared adjusted should tell you that they're used as variables. How comes it's not more substantially shown? So should I just not trust R squared adjusted and just go with R squared?
Yeah, I mean, mostly, it is always R square, and, any regression that you perform, R square and R square adjusted is, or you just send me an email with all the details, probably I might not be able to understand your question. However, I have some other data that I can show you with, for example, before going into that, just a minute.
So Mike, I do a little bit of regression analysis for my job. And I mean, we almost invariably use R squared. We never use the adjusted.
Yeah.
And typically what you're going to do is when you identify variables that are basically not impacting the equation at all, you just yank them out and you rerun it. And then you don't have to worry about using the adjusted. So, I mean, practically nobody uses it.
Yeah, practically, but, it is more precise value than R square, which is just decimal difference. If you use some other R square, regression, I have, I can pull out some other data after this and I can show you. So technically, as he's saying, Rob, that, practically only this is used. The second thing.
Thank you. I'll just ignore what the book says.
I mean, book is too much, in each and every aspect. If we read through, probably we need, regression itself requires entire class, because there are multiple types of regression, logistics regression, this regression, that regression. So basically, that is, always there to read. And how many predictors, this is another important concept that we need to keep in mind, that n divided by k, n means number of, so limit the number of predictor based on sample size. When n and k is small, the R square no longer gives a reliable indication. So basically this is the fit rules. So at least 10 observations per predictors must be there. And this is Ivan's rules, and this is the author rules. I mean, author of the book rules, where n divided by k must be greater than 5 observations per predictor. So, I mean, it's all, as big data you have, as better test you have. Now, another important thing about the multicollinearity in regression. What is the multicollinearity? If suppose two variables are having high correlation between them, if they have high correlation, exactly they will show the same. They will show the same, behavior in the regression equation or regression analysis. How do we check that? So, for example, there is a variance inflation factor which is called, and variance inflation factor. So first you see, this is, for example, this is very high correlation between these variables. So VIF, this is, and we get directly from Minitab, if VIF value is 1, that means no variance is there, that, you know, mild variance is there, and strong variance is there, and, you know, the VIF can go up to any value. So basically we need to check VIF. Look in, I mean, 10 is the, you know, you can say bottom line. If anything less than 10 is there with your, you can consider that in your regression. One is so look into this. We were going through, let's say this is VIF for 4.46. They are all less than 10. Means there's no multicollinearity, or you can say this is the only thing through which we can analyze the multicollinearity. Other thing, I'm just going to show you basic thing, correlation. So I'm just going to run a correlation between all of them.
You know, I will notice looking at those though, the scores that have the highest VIFs, if you look at them, are the TOEFL score, the CGPA. I think you had your was it your GMAT score or the GRE score? So it seems like it's all like the achievement level stuff. Seems like they have higher VIFs. I would intuitively think that those are probably more related to each other because they all relate to the student's achievement than they are to anything else. It may be why those numbers are skewing a little bit higher there.
Yes. So VIF, you know, for example, I'm just going through first, you know, look into this. And as you are saying, this VIF here, for example, like here, for example, here we have 4.45, 3.80, 1.7. You know, these are all under limit, well under limit. Here, as per theory, VIF, you know, where are, so the variance influx for given predictor, this is the formula. And here you can see if predictor J is unrelated to other predictors, means, you know, for example, GRE or GMAT or CGPA, they are not highly interrelated or highly, you know, related, then its RJ will be 0 and its VIF will be 1. And some possible situations, no variance, mild up to 2. And, you know, from 10 onwards, so practically this is the thumb rule, you know, this we need to go through this only. There's no limit of magnitude of VIF. VIF 10 says that other predictors explains 90% of the variation in predictor J particularly. So this indicates that predictor J is strongly related to other. So we have to as large VIF. So basically thumb rule is 10. If so, less than 10 is acceptable, to be honest. If we go into more theoretical aspect, I think it is going to take longer time and we have to go into more theoretical, but we need to just consider the thumb rule, which is this. So in our case here, all the cases are fine. Now there are three other things which are important to, you know, the errors are normally distributed, the errors have constant variation, the errors are independent. If you want to do this, you know, these are the things automatically we can do. For example, regression, the errors are normally distributed or errors are not normally distributed. So basically we have test for that. So now I'm just going to show you one thing. For example, let me go stat regression, fit regression model, and oh, sorry, storage. I'm just going to click all of them. So I want to check whether, the errors are normally distributed or not. So basically this is a residual, which is, how, let me show you what is the meaning of errors. So I think, for example, this is the ideal regression line. If this value is like, real value is here, real value is here, this here, so this difference, this plus or minus or this, these are the errors point. Now look into this. Here we have graphs, we have where we are probability plot, and okay, and residual distribution. Okay, normal distribution we are checking. Here you can see. So what is the, by default it is taking 5%. The p-value is greater than, p-value is less than 5%. Oh no, p-value is less than 0.5%. That means this is not actually, because here you can see this is, yeah, less than. So this is the normality you can see. Now I would like to check the normality of other parts, how we can check the normality. And this is the, so I go, okay, and I just check the normality of GRE, all these scores. Here I get, I think I plotted too much with this. However, if, so again, yeah, the situation is, it's a null hypothesis is, so all errors are normally distributed, errors are not normally distributed. Exactly the same based on the p-value. So if p-values are greater than 5% by default, then we can say errors are normally distributed. Here errors are not normally distributed if that is less than. So here, this is the situation. Other thing we can do by plotting histogram. So if I go here, graph, histogram, and I check this, okay, and I take residual. So basically, can you see it? Because here from these points are going out of the, this is another way to look into the normality. But so this is, these are the additional things. If you want to non-constant variance, heterosidicity, this is another thing. If, if your funnel, the plot of residual is like this, fan out pattern, this is heterodicity. And this is, so if you have these kind of situation, this is funnel in, funnel out, autocorrelation, and that we use in Darwin-Watson test. Errors are non-autocorrelated, errors are autocorrelated, and if Darwin-Watson test is less than 2, positive autocorrelation. If more than 2, so ideal value is 2. When H0 is true, the Darwin-Watson statistics will be near 2. So I'm just going to, so stat, regression fit model. And we have option somewhere in Darwin-Watson coding. I'm not graph step by results. Yeah, we have Darwin-Watson test here. What is it? Is 0.79, which is less than 2. What it says? Suggest positive autocorrelation. When do we use? But there's another thing. Ignore the Darwin-Watson test for cross-sectional data. And what is this data? This data that we are using for our Indian students, admission chances, it is all cross-sectional data. You know what is the cross-sectional and time series and different data. So we ignore this. So this is autocorrelation. Here, one more option I would like to share with you. This is assistant. Under assistant, if you go to regression, suppose you want to see, you want to simple regression, you want to use multiple regression, okay. Fit model only and optimize response. So let me go here, fit model. Here you can say is chance of admission, variables are research. And let me go, GRE, TOEFL, university statement of purpose, CGPA, research. Too many items. I think I don't know what is the. So let me take a chance here. Since I just use more than 5 variables.
That's what it said. Too many.
Yeah. So it has the limitation. You can include up to 5 variable only. Yeah, and we have more. Suppose this is the 6th variable. Yeah, and then you can go. So this is another way in order to go this. Here you can see the residual plot. You can see this is the funnel in or funnel out, and so you can see this is like funnel. So basically here in this option you can see some statement also. Here you can see some statement, and if you can interpret all these things, it is another easier way to do that. Yeah, one last thing which I would like to show is Pareto part. State, basic regression, regression, fit regression, and options, plot. Where is the plot graph? Yeah, this Pareto. Here you can see. So basically, this is a Pareto chart of a standardized effect response in first D is the one, then C, then E, then A and B. What is the D means? CGPA is the most important one. Then C means letter of recommendation in admission. Then E, research. So basically you can see the intensity, or you can say the effect, which one is more effective, which is, in this regression model out of this. Do you have any question, my dear friends? I mean, this is what I wanted to explain. And, Michael, I mean, please send your email. I will try to research and I will try to answer your question in detail.
I had a question
I think I'm good
specifically
with it.
about
I
the
think I think it's just that we don't really need the R squared adjusted.
Yeah.
Now,
yes,
you presented a lot of data. When do we use what, when, where?
I presented a lot of data. When do we use what? So we are just
When and where?
we are just using only one thing, which is regression and fit regression model. We are not using any other option. So suppose this is used in almost every cause and relations. For example, stock prices. What are the things that is, what are the independent variables that impact stock prices? For example, housing prices. I gave one of the discussion. There are many things which are decider for housing prices in any area, like the locality, how far is from the center, or city center, what income people live, and many things are there. So regression model is typically used in almost every situation in business and management, from stock prices to housing prices to product price also. Product, how do we decide product price? Price is totally depend on different features of the product. And how do we decide many things. So this, I gave the example of admission. Similarly, you can think about many situations. Yes, Edwin, you have a question?
Yeah, it's about the final. Like, is it going to be formatted like the previous finals in statistics classes where it's multiple choice, or how is that going to be?
Yeah, it will have, the final will have 20 questions, and I will give sufficient time for you. 20 questions that the most of the questions will be based on the Minitab outcome, that you just need to feed in the Minitab, and then you need to answer those questions.
Okay, so it's not going to be multiple choice though.
Yeah, it will be, it will be, yet, I just decided it would be a fill in the blanks. You just need to enter the outcome of the Minitab, which is the correct outcome, and it would be checked against the correct one. So it will have the blank space to fill the your answer.
Quick question: Will the exam include the amount of significant digits that we need?
Exam. I mean, I didn't get a question. Please.
So for the one that we have to fill in the blanks, will it be specified up to how many significant digits do we include on those?
Yeah, that I will clearly mention, up to 2 digits after decimal. After decimal, I will make it very clear instructions in the exam. Any other question?
Yeah, I just had to check on that one because 25% is a huge weight of our grade. So I wanted to be sure that I prepared in the best way possible for that.
Yeah, I mean, the questions, we have in assignment, it would be approximately, same questions. It won't be away, if you are doing assignments perfectly, you will be perfect in that. It is not just out of the box, out of the situation. Like, we are just dealing here with only simple regression. For example, look into this. How many types of regression do we have? Binary regression, partial least, different. I'm not making it, just only one part of regression, that so that you can understand. And if you are interested in future, you can explore yourself, because the basics are same, but different principles, different assumptions are made in order to do different. And even in this, here we have other, look into this. I'm not trying to impose, and we don't have, to be honest, in 6 weeks we don't have time to do all the things that I normally teach to other students in regular 15 weeks class. I teach different regression models. So I'm just focused on one thing. Is it make? I think.
It definitely helps that you've simplified it a little bit, because there's a lot more factors that we could have potentially had to study for.
I agree.
Yeah, in the book, all different kind of things are there. So, if somebody can go through the video, they can understand very easily and they can do it very easily. So
the only question I have is, I was looking over the next homework assignment, and for one of the problems, it said to calculate the p-value using specific degrees of freedom. I think it was like 44, 43, or something like that. But looking in the regressions, I'm not seeing any way to specifically set that, or even once you've done the fit regression model and it kicks the numbers back to you, I'm not seeing any way to be able to see what the degrees of freedom are to adjust for that. So is that something we need to do manually, or am I just missing?
I mean, let me go through the, basically, p-values are rightly calculated here, for example, and, you can ignore, if that is, something which is out of the box, I can, rectify that. So you don't need to worry, Rob, for that.
Okay.
You don't need to worry. Basically, you need to just calculate and interpret. Calculation comes here. Interpretation is most important.
Sure.
Thank you. Bye. Good night. Michael, any question?
No, thank you for now.
You're welcome. Bye-bye.
Thanks, everybody.
Bye.